All right, guys. Unit 2 review, problems number 3 and 4. Okay, so remember, like what I suggested when you have two terms in the numerator like we have, is to separate them. I like to write them as x over 10 plus 6 over 10 plus x over 15. Because there is a minus there, right, it's going to be minus 4 over 15 equals x over 6 plus 2 over 6. Wow, so many fractions, right? But let's get rid of them all. Let's find the smallest number that 10, 15, and 6 go into. It would be 30, right? 30 would be the lowest common denominator. So I'm going to multiply everything on both sides by 30, and that will eliminate all the fractions. And we'll have a nice clean problem. Okay, so 30 times 1 divided by 10, 30 divided by 10 is going to be 3x. 30 times 6 is 180, and 180 divided by 10 is 18. 30 times 1 is 30 divided by 15 would give me 2x. 30 times 4 is 120, and 120 divided by 15 is minus 8. Okay, on the right side, 30 times x, or 1x, is 30x over 6, and 30 divided by 6 will leave me with 5x. And then 30 times 2 is 60, and 60 divided by 6 is 10. So that was cool. All the fractions are gone. It wasn't so bad. And now look at it. We just got a much simpler looking equation. All right, now I'm going to combine all the like terms. There's only like terms to combine on the left side. 3x plus 2x is 5x. Let's see, 18 minus 8 is 10. And on the right side, nothing changes. So some of you can already tell what this is going to be, right? And we got the same thing equals the same thing. And when we try to get rid of the 5x on the left, well, it gets rid of the 5x on the right as well. And I'm left with 10 equals 10. And that's a true statement. And we can't find a specific solution for x. So there's infinite solutions. In this case, everything's just, all real numbers are solutions. And we call this an identity. Study those words, right? So you don't forget, okay? All right, what do you think? Here we go. Number 3. So I'm gonna start, I'm sorry, number 4. You know me, never been a numbers guy. Negative 4 times 2x minus 6 is negative 8x plus 24 equals, nothing's going to change, no distributing on the right. All right, we distributed, there's no fractions to clear, but there is like terms to combine on the right side. That would be the two x terms. So nothing's going to change on the left. 5x minus 7x gives me the negative 2x. All right. Now, I always like to keep my x's positive when I can. So I'm going to add 8x over to the right side to keep my x's positive. So if I add 8x and add 8x, I get 24 equals 6x plus 24. All right, there's going to be confusion on this problem, and I really want to talk about it. And if you watch this video and you aren't certain, 100% certain, then I need you to ask me about it, okay? Because we got to get this straight. Minus 24 minus 24. I get 0 equals 6x. When that happens, I know you guys are going to want to say the variables went away and say one of those special cases, but it's not. The variables didn't go away, they're still there. The numbers went away. If you're not confused by this, great, but I know so often always like, people think it's one of those special cases, but it's not. So it's 6 times x equals 0. We're going to continue to solve by dividing by 6, and I get 0 equals x. So this is like the standard normal case. X equals a number. 0 is a number. It deserves to be treated like a number. So as x equals 0, there is one solution. And it's x equals 0, and when there's one solution, we classify it as conditional. All right, and then that's it. But I just want to focus on this part. Just because the numbers go away, there are still x's there. Don't treat it like it's no solution or infinite solutions. That happens so often. Common mistake. Okay, there you go. There's both of them all solved out. Next video coming soon.